Good day, welcome to Memo's tutorials. Today we are focusing on chemistry and we'll be looking at the periodic table. So the periodic table looks like this. We have columns and periods. The columns, these columns, they give us the group number. So every column that you see is a group number. And we have periods. The periods is across the periodic table. Our first period being the one with hydrogen and helium, our second period being the one with lithium and it ends with neon, our third period the one that starts with sodium, which is Na, and ends with Ar, which is argon. Okay, so here we are required to know the first group elements, which are the alkali earth metals and the alkaline metals that are in group 2. And we also have to focus on the group's 7 elements, which are the halogens, and the group 8 elements. Okay, now I want us to focus on the group properties. Like I said, we are going to look at the alkali metals, which are group 1, and group 2 elements, which are alkaline earth metals, group 7 elements, which are halogens, and group 8 elements, which are these are noble gases, noble or innate gases. So why do we call these ones noble or innate? They've got full outer shells. They are stable. They don't need to gain any electrons or to donate any electrons when it comes to forming compounds. They are non-reactive. They don't need to react. Okay, so now we have what we call the valence electrons, which is just the number of electrons an element has to gain, or the number of elements, the number of electrons an element has to donate. For example, all group 1 elements, they will donate 1 electron, and they've got 1 valence electron, so they have a charge of +1. The group 2 have a +2 charge because they are donating 2 electrons, and then halogens have got a -1, which means that they will have to gain 1 electron. Noble gases it's 0 because they are not gaining or donating any electrons, right? So now let's have a look at let us have a look at group 1 elements. We call them the alkali metals. So whenever you're asked which group are the alkali metals, you should know that they are referring to group 1. So our group 1 metal starts with lithium and it goes all the way to francium. So these groups, they have something that is very special. Number 1 is that they have all of them, they have 1 valence electron. They have got 1 electron in their outer shell. So this means that the group 1 elements, they are ready to donate 1 electron, right? Once they donate 1 electron, they remain with a stable octet. They'll be having full shells of electrons. So these group 1 elements, they are shiny, they are soft, and they are very reactive metals, which means that you cannot find them in their pure form. They easily react. They are very, very reactive, right? Also, when you look at their boiling points decreases as you go down the group. It's very easy to boil or melt them as you go down. It becomes easier as you go down the group, which means that less energy or less heat is required to melt francium as compared to melting rubidium, right? Also, these alkaline metals, they react with oxygen. When they react with oxygen, they form what we call metal oxides, which means that when lithium reacts with oxygen, we form lithium oxide. When the sodium reacts, we form sodium oxide, potassium oxide, rubidium oxide, calcium oxide, and francium oxide, right? And these alkali metals, they react with halogens to form ionic salts, with the common salt being sodium chloride, which is the table salt that we eat. Well, it's just formed between sodium and chlorine. You know, chlorine, it's a group 7 element that we call halogens, right? So we can form lithium bromide, potassium iodide, rubidium fluoride, these group 1 elements, they react with halogens to form ionic salts. Ionic salts, they dissolve in water, they conduct electricity. We are going to look at ionic compounds as we continue, right? Another thing on these group 1 elements, their reactivity, like I said, we first talked of melting point. We said melting point decreases as you go down the group, but when we look at reactivity now, reactivity increases as you go down the group. The reason why it increases as you go down the group is because the outer electrons, that one electron now, it's way far from the nucleus. The more far it is from the nucleus, it means that there is less attraction between the electrons and the nucleus, so it becomes very easy for that particular element to react, which means that francium react very fast compared to sodium, because the one electron that is in francium is way too far from the nucleus than the one for sodium, especially for lithium. The lithium and its nucleus, they are too close to each other, right? So we also need to know that these alkali metals, they react with water to form what we call metal hydroxide. They readily react with water. So the metal hydroxides, we have lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, calcium hydroxide. So the OH, we call it hydroxide, right? So now we need to know the uses of these elements. As for lithium, it's used in antidepressant drugs. It can also be used in batteries. The sodium, we can use it in street lamps, and sodium, we can use it in table salt. Remember, the salt we eat is sodium chloride. The potassium, it's used in soaps and fertilizers. Rubidium and calcium, these they are used in atomic clocks, and francium is normally used in radioactives, right? That was it on group 1 elements. Now let's move on to the alkaline earth metals. These ones are group 2 metals, right? These group 2 metals, we're starting off with beryllium all the way to radium. They are also special. They have 2 electrons in their outer shell, and their valence electrons, it's 2. They've got only 2 electrons in their outer shell. And these ones, when we go to their melting point, their melting point increases as you go down the group. They increase as you go down the group, unlike with the alkaline earth metals. So unlike with the alkali, I meant alkali, the group 1. So now these group 2 elements, they are shiny as well. They are silvery white, and some of them are very reactive metals, and some of them they occur naturally as free elements, right? So these group 2 elements, they also react with water. We call them the alkaline earth metals. They also react with water to form what we call metal hydroxides, just like the alkali metals. They all react with water except for beryllium. Okay, our Be does not react with water. It has a very a protective oxide layer which prevents it from reacting. So beryllium does not react with water, but magnesium, calcium, strontium, barium, and radium, they form what we call metal hydroxides. So the radium will become radium hydroxide. The calcium becomes calcium hydroxide. These group 2 elements, they also react with oxygen to form metal oxides. They also react with halogens to form metal halides. It can be magnesium chloride, it can be calcium chloride, strontium fluoride. It can be anything. As for radium, it's very special. It's a radioactive element which can be used to make glow in the dark paint, right? That's how useful radium is. Also, when we look at their reactivity now, these group 2 elements, their reactivity also increases as you go down the group, just like the alkali metals, where we said reactivity increases as you go down the group, because the elements, your outer electrons, they are way too far from the nucleus, so there's less attraction, less energy is required for them to react or even to melt. So now let's have a look at their reactivity in general. It's less than that of the alkali metals, right? Their reactivity in general is less than that of alkali metals. So beryllium, we use it in telescope mirrors. The magnesium, we make alloy wheels. The calcium is for bones. Also the blackboard chalks is made up of calcium. The strontium is for fireworks and also for treating osteoporosis. The barium, we can use it for as a red poison, right? That's group 2. Now let's move on to now let's have a look at the group 7 elements. We call them the halogens. These are very colorful gases, and this is a very special group where we find gases, liquid and solids in one group, unlike the other groups where we were only told these are the alkali metals, these are the alkaline earth metals. Now we are having halogens. These are colorful elements, and we are having liquid, gases and solids in one group. Okay, as you can see, we are having our fluorine and chlorine as gases. The bromine is a liquid, the iodine it's a solid there. So the halogens, these group 7 elements, we call them halogens. They all exist as diatomic elements except for acetine, but we're not going to focus on acetine. We're just going to look at fluorine up to iodine. So diatomic means they exist in twos. Fluorine would rather exist as F2. The 2 will be at the foot of our F there. So the chlorine also Cl2, Br2, I2, At2, UUS2, right? That's how they exist. That's what diatomic means. And all these group 7 elements have got 7 valence electrons, which simply means they've got 7 electrons in their outer shell. And for them to have a full shell, they only need to gain 1 electron. When they gain 1 electron, their charge then becomes -1. Okay, they all have a negative charge of 1, which simply means that they have gained 1 electron, right? When we look at their reactivity, it decreases as you go down the group. The reason being, it becomes very hard to add an electron as you go down the group, right? I'm sure you can see we're starting with the 9 electrons and all the way to 117 electrons. It becomes very hard to add an electron where we have got 117 electrons. I hope you still remember the number of electrons and the number of protons. They are exactly the same. And the number of protons, we also call it the atomic number. All right, so now these halogens, they form acids. When you react them, they form acid. And like we have got hydrofluoric acid. This is between hydrogen and fluorine, which we use the hydrofluoric acids. We have got the hydrofluoric acid, which leaches calcium from bones and can cause very painful pains. It also dissolves glass. That's how dangerous the acid is. These halogens, they react with oxygen to form halogen oxides. The halogen oxides will react with metals to form metal halides. We have spoken of metal halides. We can have potassium iodide, sodium chloride. All those are metal halides. Now, when we look at these halogens, they are very good oxidizing agents. While they are halide ions, they are also used as what? Reducing agents. So if you are having F2, the fluorine on its own, it's a very good oxidizing agent. But when we have I-, which means it's a sodium, it can be sodium iodide. It's an iodine that has reacted with something. On its own, it then becomes a reducing agent. So uses of these halogens, they are very useful. I'm sure you've seen that most of the toothpaste, it has got fluorine. It is also used as a refrigerant gas. Chlorine is mainly for bleach, for purifying water. We use chlorine. We have bromine. which also used as a fire retardant material. We've got iodine, which is used as disinfectants, right? So that was for group 7. The last group, which is a very, very special group, is the group 8. We call it the noble gases. The noble gases group. This group has got elements that are odorless, colorless, monoatomic gases with a very low chemical activity. So these ones, they are almost non-reactive. Their boiling points, all their boiling points are less than 0. These noble gases, they are all monoatomic, meaning to say they don't exist in twos. If it's He, it's just helium. It's not two heliums that exist together. And these ones, they really form compounds, which means they really react. Okay, and in their outer shell, they are full. They've got full electrons in their outer shell. They are not lacking anything. And their valence electron, their valence is 0, and their outer shell is 0. Okay, so these gases, like we said, they are colorless. And then we have got helium, neon, argon. We're just going to focus on those 3 first. The helium, neon, and argon. We've got about 75% of helium, 23% of we have 75% of hydrogen, 23% of helium, and 1% of that over there. So helium is the second most abundant element in the universe. So in the universe, helium is the second most abundant element. The other is for oxygen. So now we have got radon. Radon, the one with 86 protons there, is a radioactive and can enter homes through basements after radioactive decay of rocks below the Earth's surface. So what are the uses of these noble gases? Since we say they don't react, they've got very low boiling points, they are colorless, monoatomic, they are full, So what are they used for? Helium, it's very common. Mostly when we have parties, we blow helium in our balloons, right? And the balloon, if you lose it, it will keep on going on and on and on because it's very light. Neon is used in lights and as a refrigerant gas as well. Argon, it's used in medical lasers, even light bulbs. Krypton is used as camera flash, and then xenon, we use it in the medical field. So that's all on the periodic table. Thank you.